All right, so I'm going to go over a couple quick examples of Pythagorean theorem and distance formula. As a reminder, Pythagorean theorem, let's go with blue. Pythagorean theorem is a squared, wow, that was a lovely A, plus b squared equals c squared. Okay, so here we're talking about right triangles. C will always be the hypotenuse, so that longest side, the one that's opposite of that right angle. A and B can be either side. Let me do a good A. This could be A and B. You could also have A here and B here. It doesn't really matter. As long as C is the hypotenuse, the other two can switch around. Okay, so let's go over some examples really quick. First question. Use the Pythagorean theorem to find each of the missing side lengths. Only one missing side length here. Let's match our picture and go with purple. Okay, so we have a right triangle here. We know that one of the sides, we'll call this one A, is 5. We know the other side, B, is 2. And we want to find C. We don't know what C is yet. So the first thing I'm going to do is basically just substitute the numbers that I do know into the formula. So I'm going to rewrite the formula again. A squared plus B squared equals C squared. Okay, so we know A is 5, so I'm going to substitute 5 in for A. We know B is 2, so I'll substitute 2 in for B. And we don't know C, so I'll leave that as C. My handwriting is so lovely today. Okay, so now to solve for C. First thing I'm going to do is square 5 and 2. So 5 times 5, that gives us 25. 2 times 2 gives us 4. That's still C squared. Can't really do anything with that yet. Next thing I'm going to do is add these two. We're going to combine those like terms. Okay, so 29 equals C squared. Now, we're not done with our answer yet because we want just C. We don't want C squared. We want just C. So to get C unsquared, we take the square root of that. And if we do this something to one side of the equation, you have to do it to the other, right? Keep the balance. Keep the balance. Of Star Wars. Balance in the Force. Okay. Keep that balance. So we take the square root on both sides. And if we take the square root of 29, now a lot of assignments, and some teachers will let you just keep it as square root of 29. Let's say we want to find the actual like decimal, right? Rounded to the nearest hundredth. Okay. So square root of 29 is going to give us 5.39. So now we know side length C is 5.39. Okay, I did write these steps out because on the assignment that I'm going to give you guys, you'll have multiple choice for this particular question, this one. But you're going to have to actually explain to me in the next question how you found your answer. Okay, you're going to have to explain it in words, okay, how you found the answer. So this is just an example of what that would look like. So you can pause the video, look at this, look at kind of the words that I used. So, step 1, wrote the Pythagorean theorem. Then I replaced A and B with the numbers that I know. Then I squared those numbers, added them, took the square root of both sides. Okay, so this is what I mean by explain in words how you found the answer. Okay? All right, next example. Use Pythagorean theorem to find each of the missing side lengths. So here, this one's a little bit different. On this one, we actually know the hypotenuse. We'll call this one A, but we don't know one of the other side lengths. We'll call that one B. Okay, so we're going to be working a little bit backwards from the example we just did. So first step, I'm going to write Pythagorean theorem out. A squared plus B squared equals C squared. Second step, I'm going to replace the numbers that I do know into the formula. So we know A is 3.6. We don't know B, so I'll just leave it as B. C is 7.4, so I'll replace that there. Okay, now next step, same as before, I'm going to square those numbers that I do know. Okay, so 3.6 squared, sorry, 3.6 squared is 12.96 plus b squared because we don't know b yet, and then 7.4 squared is going to give us 54.76. Okay, now we want to isolate this b squared. To do that, we need to get rid of this. By get rid of, I mean we want to move it to the other side of the equation. Since it's positive, we can do that by subtracting it. 2.96. But if you subtract on that side, you have to subtract on the other side as well. So 12.96 minus 12.96, that gives us 0. So that just cancels out. We're left with b squared equals, and then we'll do 54.76 minus 12.96, and we get 41.8. Okay, again, we're not done yet because we want just b, not b squared. So we're going to take the square root of both sides to get that b by itself. And if we take the square root of 41.8, we are left with b equals 6.47, rounded to the nearest hundredth. Okay, so now we know side length b. So you can use Pythagorean theorem not only to solve for c, but you can solve for b and a, right? It's just like a multi-step equation, right? Solving for a two-step equation, right? We need to isolate b squared or isolate a squared. Same concepts there. Okay. Now, again, on the next question, you'll be asked, explain the steps you use to find your answer in words. Okay, so here's just an example of that. Basically the same as the one above, right? You write the Pythagorean theorem, you replace the numbers you do know, square them, subtract something from both sides, take the square root. Okay, so this is what I mean by explain it in words. Okay, all right, we're going to move on to distance formula now. Okay, so distance formula, and we've gone over this before, but I'll just do this briefly. Distance formula. Basically, d in this equation is the length of the hypotenuse in a right triangle. Okay. So usually with distance formula, we're talking about the distance between 2 points on a coordinate plane. Okay. So C for our hypotenuse in Pythagorean theorem, that's going to be the same thing as D here. Okay. D in the distance formula is the same thing as C in Pythagorean theorem. Okay, it's just the distance between the 2 points, right? And we can find that distance really by finding that change in x, or in other words, we're finding the difference between one of our x coordinates of one point and the other x coordinate from the other point. Same with this side. Here we're just finding the change in y. Change in y, which essentially is just the difference between the two y coordinates that we have. Okay, so that's where these come from, and I've gone over this in length in other videos, which is why this is kind of just a brief overview. But hopefully that reminds you what distance formula is. Okay, so basically that the x1 minus x2 here, That's the horizontal side of the triangle, right? Because it's the distance on the x-axis. y2 minus y1 is the vertical side of the triangle. Okay, that up and down. All right, so let's go over some examples of distance formula then. Let's say we're given 2 points on a graph and we want to find the distance between that pair of points. Okay, let's use green. So we want to find this length right here. Now notice I could actually draw a line there and draw a line there and make a right triangle. So really this is side A of our triangle, B and C. Okay, but since we're talking about distance formula, I'm gonna replace that C, that's my replacement, with a D. Okay, and B there is just gonna be our change in x, so the difference between the two x coordinates, so 5 and 1, and A is going to be the difference between our two y coordinates, 5 and 2. Okay, so let's start by writing out the distance formula. D equals square root of x2 minus x1 squared plus y2 minus y1 squared. Now again, that x2 minus x1, that's essentially just, let me grab a different color. That's the change in x here. So how many units are we moving from this point on the x-axis over to this point? So really, if you're given a graph, you can even just count, right? We're going 1, 2, 3, 4. Okay, if you're only given the coordinates though, the way I like to write it out is kind of stacking the coordinate pairs. Okay, so here we have our x's, here we have our y's, right? So really we're just finding the difference between the two x's, right? What's the difference between 1 and 5? We know that difference is 4. Okay, and y2 minus y1, again, that's just the difference between the two y coordinates. So what's the difference between 5 and 2? It's 3. Now, technically, if you were to substitute those numbers in, like 1, 5, 5, 2, you're going to get a positive number over here and a negative one over here. But because we're squaring those numbers, it'll always end up positive. Okay. All right. Okay. So, next to solve, we are going to square 4 and 2. Sorry, 4 and 3. Getting ahead of myself. Okay. 4 squared. 4 times 4 is 16. 3 times 3 is 9. Equals D. We're going to add 16 and 9 next, right? Just combining those like terms. And then we take the square root of 25, which we know is 5. 5 times 5 is 25. Okay, so there is the length of side D. Okay, so again, distance formula is basically the same thing as Pythagorean theorem, just written slightly different. But you're doing the same steps, right? We're squaring something. Oops. We're squaring two different side lengths, taking the square root to find that third side length. Okay. Okay. Again, you'll be asked to explain how you found that answer in words, right? So here's just an example of that. So we wrote the distance formula, right? We replaced the numbers that we do know. We squared those numbers, added them together, then took the square root. Okay. All right. Last example. Use the distance formula to find the distance through each pair of points. So here we're not actually given a graph, we're just given the 2 points. So I'm going to walk through this how I like to do it. Again, There's multiple ways to do everything in math, right? But this is just the way that I find most intuitive. Okay, first thing I'm going to do is just stack those 2 points. Okay, and we know that this side is x, this side is y, right? So it's kind of like we have a table here. All right, I'm going to write the distance formula next. So d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, keeping it real. Okay. All right, so this first part. What's the difference between the 2 x points? So what's the difference between -2 and 6? Again, difference just means subtracting, right? So if you're looking at a graph, how far are we moving on that axis from the point 6 to the point -2, right? Or 6 plus 2. Subtracting a negative is the same thing as adding. So that'd be 8. So I'm going to write 8 there. And then the distance or the difference between the 2 y points, 3 and 4, the difference between 3 and 4 is just 1. Okay, next thing I'm going to do is square those numbers. So 8 times 8, 64. 1 times 1 is just 1. Then we'll combine those like terms. 64 plus 1 is 65. And the last step again will be to take the square root of 65, which if we do that, we get 8.06 rounded to the nearest hundredth.